Morning, everyone, and welcome back to the course number 8 in Business Digital Architecture courses. Today's subject is about IoT, Internet of Things. Of course, as an architect, it is very important to have a general idea about how this technology work and, of course, the architecture behind. In this video, I will try to present the IoT in general, the architecture used in this technology, of course, the cloud, edge, and fog computing used, data management and analytics, the performance metrics, of course, of this aspect, and at the end, a quick demo uh, to present in details how this technology can be helpful and how can we use it in daily needs. So let's start with the quick definition. What is IoT? As you know, it's Internet of Things, but more in specifically, it's an architecture composed of many technologies working together to provide services by connecting physical objects to the internet. So it's not just a technology, it's not a paradigm, it's not um, new apps or new aspect in programming. It's a whole new uh, architecture and system design that provides service based on many other technologies. If that seems abstract, here is some examples that we use IoT in nowadays. For first one, we have smart thermostats, of course, to adjust the home temperature and to monitor in real time data the state of our house. Second example, we have smartwatches and fitness track, of course, for heart rate, sleep schedule, etc. We have smart homes, security cameras, a smart refrigerator. We can push this idea high and even suggest new recipe to prepare based on what we have in our refrigerator. And of course, ad hoc communications like connected cars, smart cities, etc. So, what is the architecture behind IoT or Internet of Things? We have a quick illustration here that present the architecture in five main different layers. Let's start from the bottom up. Here we have like the um, physical device or sensor layers layer. Um, in this part, we have the hardware research that collect data that is in real and direct communication with the environment. And of course, after we collect data, we need to transmit it and to send it to somewhere to be processed. And here it comes like the second layer, the network communication layer. Here we can use many different technology in networking, like mobile networking, wireless communication, any different local communication like Bluetooth, etc. And of course, this is very important because it's, as we will see after. It's among the metrics or the performance metrics of our IoT products. Of course, after the transmission, we have the main or the most important layer, which is the brain of our AUT, is the cloud part. So here we uh, actually do a lot of works, processing data, storing data, predicting, analyzing, transmitting, forwarding, etc. And it's very important because it provides services both for the upper part layers and the bottom part layers. So we cannot have an IoT product without actually having a very strong cloud provider. So this is a very important thing to be considered in our um, conception of any IoT products. What's after the cloud part? We have applications, business logic layer. Here we have just like the end use application by the users. Uh, for example, the apps in our phones, the dashboard, web app we use, etc. And of course, at the end, we have the user that use the applications and that, of course, consume the service provided by the whole architecture. So for the cloud part, I presented quickly the layer and why it's very important, but actually cloud is not just the main technology used in IoT because we have two different parts or two different aspects that can be used for more efficiency, more reliable latency, and in general more performance. And among those technology, we have the Edge one. So Edge is the local processing. It's like in this part, in every hardware or every physical resource, we have a small brain that collect data, analyze it, and take action locally. We don't transmit data to via the network to the cloud. We just do a quick behavior in local processing. As an example, we have Google Distributed Cloud Edge as Coral. And the second one is the fog. Fog is the uh, intermediate layer between the cloud and the edge. It's based on nodes and gateways. If you want, it's like uh, the parts used to distribute cloud services. And as an example, we have Google Distributed Cloud, like hosted or virtual. Or the cloud layer, as you know, is like digital resources as a service. We have many different technology like software as a service, for example, Gmail, Google Docs, etc. Platform as a service like App Engine, Google Functions, Firebase, etc. Infrastructure as a service for compute engines, cloud storage, and so on. And even we have a network as a service, for example, for those who want to create their own private network or VPN, extra. So this is a very important part of IoT architecture. We need to know what exactly need to use in our product. It's like cloud, edge, fog. What is the most valuable one? What is the most performance one? And this is, of course, based on the context. For the IoT data management and analytics part, of course, data is also a very interesting and important aspect of the architecture. All what we do is collecting data, processing it, and provide a service based on that data collected. So we need to do those four um, services to be able to have like a product or an IoT product that is helpful and useful by the users. First one, of course, we need to collect and store the data. Of course, every part is provided by the cloud. For example, storage, we can use Firebase or any other cloud providers. In this presentation, I based on products provided by Google or the Alphabet company. So you can, of course, use any different cloud provider to do those to have those services. So we do data storage and then data processing, like proven response, like for example, cleaning data, future engineering, separating data, etc. Of course, after visualization the data, it's very important. As you know, having the data is really uh, complex to be analyzed and processed without understanding it. And to understand the data, the most efficient way is to uh, visualize that and illustrate it into diagrams. And of course, after we have data analytics, like we can do machine learning, predict based on the data, training models, and so on. With performance metrics, or what make our IoT product performance, we have like those um, main metrics. Like the first one is quality of service. It's it's like the most important metrics because what actually user needs is a service that is functional and with high quality. And if you want, it's like a general part that englobe every single one of those aspects. So in quality of service, we can like speak about talk about latency, reliability, availability, etc. And just after we have the quality of experience, it measure how users perceive the service quality. And this is how we know like that the user is having or enjoying the product and if it's respond to his needs. After we have latency, for example, of course, for delay communication between networks, as I presented, we can use local networks and even mobile or even the internet. So latency is very important for real-time data processing. After we have efficiency, energy efficiency, uh, here we're talking about batteries because course, hardware to be used, there needs energy, and the source of energy, the main resource of energy is batteries. Um, so it's very important to have like a very efficient energy, very efficient energy service. After we have the scalability, using a product used by 10 users is not like the same product used by thousands and millions of users. So our product need to be scalable, and this is will be uh, possible thanks to the cloud provider we choose. And at the end, we have accuracy of analytics and predictions. Of course, it's a part of everything. We need a product that is like accurate of what we need. I don't just need a product that provides anything like, yes, we process the data and we have results, but those results, are they like true? Are they helpful? Are they useful? Extra. So this is the quick presentation of the IoT architecture and IoT aspect or technology in general. Now let's dive into more detail with the demo using ThingsBoard. So just op- if you don't have an account, you need to create an account in this platform to be able to use those services. It's free. We have free tier for 1 month, and of course you have uh, a limited usage, like number of device to add, a number of dashboard, etc. As you can see here. So the idea of this demo is we will create um, um, a small service or IoT product that collects data and showing it in the dashboard. It's like a basic one just to show you how IoT is used in real life and, of course, how it can be helpful. And ThingsBoard is like a platform used in IoT technologies. It's like very simple to use, and it's a SaaS as a service, like software as a service. So you don't need to configure anything. You can just create an account and start using it. So to start, we need to create a device. Like we start with, as I presented before, with the bottom part, this part, we need a device. So let's create a new device. So entities, devices, add new device, and let's choose a name. So let's call it my device, and let's keep everything by default. And here we need to take this one. It's like the command we need to use to send the data. As you can see, it has the curl. We can use it in the bash commands, and we have the post methods and the URL used. We have the ID, and we have the header, of course, and after we have the data, and we can, of course, like personalize the data sent here. As you can see in here, we send um, copy, we send temperature by default. So I will save this one, close, and voila, the device is created by its inactive. So I will keep this command here, and I will create a dashboard to visualize the data shown or sent by the device. The network part is um, managed automatically by the ThingsBoard service. The cloud part also, and we have for the application we can just use this dashboard for final user. So add a dashboard, create new dashboard, my dashboard, and okay, do I need to add anything? No, add. So add a new widget like a widget to present the data. We'll choose a basic one. So let's take this one. And okay, I need to choose a device. I already created my device. And okay, I need to show the temperature. Good. And okay, add. So as you can see, the widget is like empty for now because we didn't like send any data so far. So to send the data, I can just use this one, and I will, sorry, I will, I prefer to use Bash like it's already installed in my VS Code, and it's sure that it will works because this is a Bash command. So here the Bash command, so I will copy paste this one and send it. So good, we can see that the API was called successfully. So let's see, and good, we can see the data. We sent like 25 into picture, and to be sure, it's just to save this one. Be sure I will go to device, click on device, the latest telemetry, and we can see the data sent here. I can do that again and send in a different data, for example, 27, and we have 27, and in the dashboard we have another point added to our dashboard. I will do that again and again. I mean, I can create a script to I can create a script to automate this this behavior, but for now it's just like for a quick demo, so I will not do that. So you can see I send a lot of data and I still have the all the data sent so far. And you can do more technical stuff by adjusting the rule chain. We'll just present quickly what we are doing here. So, well, device profile default. So just my device, as you can see, it use the device profile, default device profile, and this this device profile, the default one, is use the default rule chain. This is why I will show you the default rule chain, this one, because it's the one that manage the data sent and all the behavior of our application. So we have the input like the 25 data sends or temperature data, and we have like a lot of scripts and a lot of um, stage where we process data, and we you can add alarms here. You can add conditions, you can add another logic, of course, by drag and drop these services here. So I think this is it for the demo. It's a quick one just to give you a general idea. And of course, um, I will provide all the documents used in this presentation, just next to the video, even the illustration and all the docs, of course, use. Okay, thank you so much, and see you next time.